Hello, dear students. So, in previous class, we have already completed our first chapter of class 12 NCERT portion of physics. That was electric charges and field, first chapter of physics. So now we will see some questions also on like that chapter. We have already covered many questions on this chapter, but we will see like more questions on this. Let's start. So this is the example, second example of this. So just a second. Yes. What it says, let's read out. Three charges Q1 1 microcoulomb, Q2 is minus 2 microcoulomb, and Q3 is 3 microcoulombs are placed on the vertices of an equilateral triangle of side 1 meter. Find the net electric force acting on the charge Q1. Okay. So here three charges are there. Q1, Q2, Q3. Their magnitude also are given here. So we have to find the net electric force acting on charge Q1. So here Q1 charge has what are the charges will exert force on Q1? That will be Q2 and Q3. Okay. So charge Q2 will attract charge Q1 because charge Q2 is like what? Charge Q2 is your negative and charge Q1 is positive. So it will attract it. Okay. Along the line joining them. So it will act like this only. And Q3 will also attract repel because Q3 is positive charge, so Q3 will repel Q1 and the force will act like in this direction. Okay, outward direction. So let's find out that what is the vector addition of these forces. Let's move to the next page. Okay. So method one is showing here. There are two methods. We will see one by one. Let's remove the drawing here. Yes. Just a second. Yes. So method one is given here. We have two forces, that is F1 and F2, which I have already shown you. I have already shown you that F1 will act in this direction and F2 will act in this direction due to Q3 force, and F1 is due to Q2 force, like Q2 charge, and F2 is due to Q3 charge. So their directions are like this, and the angle will be, this is 60 degree. So this angle must be 120 degree due to your linear angle pair. Okay. So then a net force direction will be like this. Okay. And suppose that it makes alpha angle with the like F1 direction. So here F1 magnitude is what? K Q1 Q2 by R square. Okay. Okay. So magnitude of forces between Q1 and Q2 will be what? K value is 9 to 10 to the power 9, then 1 into 10 to the power minus 6 into 2 into 10 to the power minus 6 upon 1 square. The distance between them is 1 only. This is 1 meter, so 1 square. So their magnitude is coming out to be 1.8 into 10 to the power minus 2 newtons. Similarly, the F2 force magnitude is given like K Q1 Q3 by R square. K Q1 Q3 by R square, this force F2, because it is acting between Q1 and Q3 only. The magnitude of force between Q1 and Q3 will be like 9 into 10 to the power 9 into 1 into 10 to the power minus 6. That is the magnitude of your like a Q1 charge, and Q3 charge magnitude is 3 into 10 to the power minus 6 upon 1 into 1 whole square. Why we have multiplied 10 to the power minus 6 here? Because of charge is given in microcoulomb here. So we should multiply 10 to the power minus 6 here to change the microcoulomb charge into coulomb. So this value is coming out to be equal to 2.7 into 10 to the power minus 2 Newton. Okay. Now I have to find net force acting with on Q1. So I will vectorially add F1 and F2. What is the vector formula of adding any force? Two forces. So F net will be like your root F1 square plus F2 square. Okay, plus 2 F1 F2 and angle between these forces. What is the angle between these forces? Join tail to tail and see the angle between them. This is 120 degree. So cos 120 degree. Okay. just calculate this value, you will get the final answer. So here I just show you that what is the final answer. If you do the calculation part, so it is coming out to be equal to 2.38 into 10 to the power minus 2 Newton. Okay. Yes. So this is your final answer for FNet. And here the angle tan alpha is what is the angle FNet is making with the F1 force is equal to F2 sin 120 upon F1 plus F2 cos 120. This is the your tan alpha formula for your vector. You have already studied in class 11. So this is your formula, and you will get the answer equal to 79.2 degree your alpha value. Okay, you have to use the calculator also here. So this will give you 79.2 degree. Thus the net force on charge Q1 is this, and the angle is 79.2 with a line joining Q1 and Q2 shown in the figure. This was the final answer, and it was method 1 for solving this. Okay, so just now we have seen method 1. We will see that what is the method 2 for this. So yes, let's move forward. Method 2 is in this method, let us assume a coordinate axis. So we will assume any coordinate axis with Q1 at origin. Q1 is placed at origin as shown in the figure, and the coordinates of Q1 and Q2 and Q3 in this coordinate system are Q1 is already in origin, so 0, 0, 0. Then Q2 is where it is at 1, 0, 0, because it is on x-axis, and Q3 is on your 0.5 in 0.87, 0. Okay, this is the you can also find out this coordinate of Q3 by just doing calculation part. Okay, because here x distance is what? X is half. This is 1 meter, so this will be 0.5 meter. Okay, the x value is half for this. That is why it is 0.5 coordinates for x. And y coordinate, how to find the y coordinate of this? So you have to just find out y coordinate here, and it was already given also here that it is 0.87 meter here. Okay, you can see here if you find out this distance by Pythagoras theorem, that it is 0.1, and this distance is what? This is your 1. Okay, so you have to calculate it by Pythagoras theorem. So it will come out to be 0.87 meter. Okay, and by the z axis distance is 0 only, because it is in xy plane. So okay, so you can find out coordinates of Q3 also. Now you have to just do the calculation part now, right now. So force on Q1 due to charge Q2 will be this value will be like this, and vector you have to write the equation of F1 force in vectorial form. So R1 minus R2 should be there in the numerator part, and R1 minus R2 cube also there in the denominator part. Why is this coming here? So just a second, I will explain you why it is coming here. I have to clear this. Okay. So R1 minus R2 is coming here. See here why it is coming, because you can observe here that this Q1 and Q1 and Q2 are if you see here. Okay, just a second. Yes, this is your you can say that this is R1 position vector, this has the R2 position vector, and this has the R3 position vector. So if you have to find the force between Q1 and Q2, so you must write the distance as R2 vector minus R1 vector. Okay, but why it is so? Because you already know that the resultant of position vector R is equal to R1 or R2 minus R1. Okay, this you have studied already in 11th class. That is why it is written like this, R2 minus R1. Okay, so yes, so here you can see that R2 minus R1 or R1 minus R2, you can take both are same. So R1 minus R2 he has taken R1 minus R2 whole cube. So you will get the answer as 1.8 into 10 power minus 2 I cap Newton. So this I cap is showing the direction of F1 force, that is in the positive x direction. Similarly, force on Q1 due to charge Q3, that is denoted by F2, is equal to 1 by 4 pi epsilon naught Q1 Q3. Here R1 minus R3 will come because there is the position vectors are r1 and r3. So therefore r1 minus r3 in the numerator part, and in the denominator part it will be your r1 minus r3 vector. Just a thing. Yes, r1 minus r3 vector whole cube. This is vectorial form. I have already talked to you that the your Coulomb force in vector form is like a q1 q2 upon r cube into your r vector. Okay, like this only. This I already told you that this is the vectorial form of like writing the your Coulomb's law, and you can see the like lecture of this like first or second lecture of this chapter. So yeah, you can follow all the lectures on the channel of GoAsk Academy. So yes, let's try to figure out that what is the answer of this. Yes, the answer is coming out to be equal to your f2 is coming out equal to 1.35 I cap with minus sign minus 2.349 j cap into 10 power minus 2 Newton. So this is the like your f2 force in vectorial form. Why these are coming? Because the direction of f2 vector is in the like minus I cap also and minus j cap also. Both the components are there. You can observe also here that the direction of this force is like in this direction. Okay. Yes, it is in this direction. So it has like minus x component also and minus y component also. Okay. That is why here minus I cap and minus j cap are coming. So just to remove these drawings. So I suggest you to follow the method one only, because it was easier for you to calculate the force value, and second method is little bit lengthy and confusing also for you. But you should know the method, but don't try like both methods. You can stick with the first method also. Okay. So yes, let's move forward and see that if you calculate the net force on Q1, that will be resultant of like F1 plus F2. So F1 plus F2 you can calculate like adding the I components together and J components together only. So that will give you 0.45 I cap minus 2.349 J cap into 10 power minus 2 Newton. So I hope that you got this question, and let's move forward and see that what is the next example. So I have taken good example for you only. That will be like your board level also, and it will cover your IIT level also. Okay. So let's see the example second of it. Two identical balls, each having a density rho. So there are two identical balls, and both have having a density rho are suspended from a common point by two insulating strings of equal length. So they are in suspended from a common point, and they are suspended by insulating strings of equal length. Both the balls have equal mass and charge. Mass and charge are equal here. In equilibrium, each string makes an angle theta with the vertical. So in equilibrium, if you disturb the system and they were present previously in equilibrium, their net force will be like 0. Okay. So now both the walls are immersed in a liquid. So both walls now are immersed in a liquid. As a result, the angle theta does not change. So theta will not change here if the both poles are immersed in a liquid here. The density of the liquid is your sigma. So density of liquid is given as sigma. Find the dielectric constant of the liquid. So it is a like good question, and we have to find the dielectric constant of the liquid. Each ball is in equilibrium under the following three forces. So there are three forces which are acting on both the balls, and the forces are here like tension force, active force, and weight. Okay, so you can observe here also from the figure that there are three type of forces here. Here, if the ball is like here hanging and like making theta with the vertical, okay. So there are three forces that take tension force acting or like upward direction, because it will try to pull it. So tension force will act like upward direction, and this is your electric force here, Fe. Okay, and okay, this electric force is due to this ball because both the balls are hanging here. See here, figure in the figure, you can see and observe this. Okay, just a second. Yes. So this is electric force due to repulsion, and here weight is acting also here. Okay, this is in vacuum only. So in the liquid you have what? Fe will change into F like Fe dash because the dielectric medium is there in liquid. So Fe dash will become Fe by K. That I already told you that what is the value of force inside any medium that will be equal to Fe by K. Okay. So let's move further and where K is that the constant of liquid and W dash is what? Here W dash is W minus upthrust. Okay. Why upthrust? Because liquid is there, so upthrust force will act. W dash will be what? One weight is acting of like this ball, and here buoyancy force or upthrust force will act. So this its resultant like W minus upthrust is W dash. Okay, let's move further and see the like further calculation of this. Yes. So we have applied here Lami's theorem. Lami's theorem is like if you have three forces, like if you have F1 force, F2 force, and F3 force. Okay, like they are acting like this only F1, F2, F3. Okay, just a second. Yeah. Like F1, F2, and F3 forces are acting here like this, like they are passing through a single point, they are congruent, and angle between them is like theta 1, theta 2, theta 1, and theta 3. So you have the relation that f1 by sine theta 1, okay, equal to f2 by sine theta 2 equal to f3 by sine theta 3. What does it mean? It means that whichever force you take, the opposite angle of that and its sign will be like their ratio will be equal to the other force and opposite sine angle of other. Okay, like sine theta 2. So you have this relation by Lami's theorem. So see here, it's like we have applied the Lami's theorem in vacuum also. So here you can observe that W force is acting like this only. Here W force is acting like this, and this angle, opposite angle of this is what? You can see that this is 90 degree and this angle is theta degree. Okay, because this is theta, so this will be theta by alternate angle. So in the opposite side of W, the angle is sine 90 plus theta. Okay, this will be your trigonometric ratio opposite to W force, and it will be equal to what? Observe here. Yes. So it will be equal to Fe by sine 180 minus theta. So Fe force is acting here, and this angle opposite to this force, the angle is like this. So this is what? This this angle is 180 degree, and this angle should be like 180 minus theta because theta is here more. So theta will be subtracted with 180. 180 minus theta is this one angle. Okay, so that is why we have taken this angle 180 minus theta. And if you like substitute the all the terms here, you will get what? Okay, so you will get W by cos theta because 90 plus theta is what? Cos theta, and Fe by sine theta. Sine 180 minus theta is sine theta. So you similarly liquid what you will get? W dash by cos theta because the angles were same, and Fe dash by sine theta. W by cos theta, W dash by cos theta is equal to Fe dash by sine theta. Angles are not changing, so we will get the same value. Dividing equation 1 by 2, what do you get? So if you divide like equation 1 by equation 2, like this equation is divided by this equation. So W by W dash will be there, and Fe by Fe dash will be remaining here. Okay, and K is what here? K is W by W minus upthrust. Yes. Okay. So you can substitute the value of w. The you can also see that your weight can be written as, you know, the formula of weight, that is rho gv. If you have studied the fluid mechanics, the weight formula is rho gv. Okay, this is the formula of rho gv, because you know that the mass is density, like your density is mass upon volume, so density into volume. And like if you multiply it with g, then you will get weight, because weight is what, mg. So rho vg is your weight formula. So here you can substitute the value of w is equal to rho gv. That is the volume. This is the volume of your what, ball. Okay, and here you can substitute rho gv again, because w is already there again here. And here you will substitute sigma vgy, because there you have the buoyancy force. And buoyancy force value is what? If you have studied fluid mechanics, so buoyancy force value is rho of your liquid into volume of your body immersed into g. That is why we have it is equal to rho of liquid, which is here sigma into volume of whole body is immersed, so into g. That is what this formula is there. And if you now cancel out the like terms here, so gv will cancel out, and it will be remaining a rho upon rho minus sigma. Okay, so k value has come out here, rho upon rho minus sigma only. Okay, yeah. So this was like your this question. And why this the equation have come, you can see that fe by fe dash is equal to k only, dielectric constant. So that is why here k is coming here. Okay, so I hope that you are clear with this question also. This was a good question. So yes, we have seen some examples of first chapter here, and we will move further and see another examples which are good in your concepts. Okay. So here is one topic you should know, that electric field of a line charge. So what is the electric field due to a line charge? If you have positive charge q which is distributed uniformly along a line with length to a. So here the line length is to a, and lying along the y-axis, it is lying along y-axis between y minus a and y plus a. Okay. So you can observe there, this type of question also can come in your boards or like your exams. So I will explain this also. Okay, see here, if you have a line chart like this is 1D, only it has one dimension. So here it has positive charge, and its the dimensions are like it is placed on y-axis, and it is going from here, it is origin in the center. So the length will be in this direction is minus a, and in this direction the coordinate, like length will be a only, but coordinate will be minus a comma, like 0 comma minus a, and here the your coordinate will be equal to 0 comma a. Okay, so like limits are going, like y is going from minus a to plus a. Okay, so we are here interested in finding the electric field at point p on the x-axis, on x-axis only. Like if you have any point on x-axis p, so what is the electric field on this point due to this line charge? So let's find out that how to calculate the electric field on this point. So suppose this is a whole like line charge, so you cannot apply Coulomb's law directly here, because it is a continuous charge distribution, and Coulomb's law is valid only for point charge. So we have to take some point element here. Okay, so I have assumed a dy element here. This is point element dy at a length of y distance from your origin. So whenever there is your questions of continuous charge, you must apply integration method. Why? Because we don't have formula for continuous charge distribution. We have to apply integration. Therefore, coming up the point charges, like continuous charge are divided into point charges, and we have to sum them. So that is why integration method is applied here. So we have taken dy element of this line charge at a y distance, and its distance from p point is small r. As they put small r. So what will be small r? It will be root f square plus y square. By Pythagoras theorem, it will be root x square plus y square. It is x and it is y, so it will be root x square plus y square. Okay. So let's move further. Yes. So here lambda is what? Charge per unit length, because we have to see also here what is the linear charge density. So lambda will be your unit charge density here, and it will be equal to what? Q is the total charge on the this line element, or this you can say that whole length of this element, and Q by 2a is the length of this line charge. So Q by 2a is the lambda value. Okay. So dq value is what? Dq must be equal to lambda into dy. This is your formula for line charge distribution. Point charge, like point charge formula is what? Dq is equal to lambda dx or lambda dy. I have already told you this in previous lectures. Okay. How to take the point element on any continuous charge distribution. So the point charge for this element is lambda dy. Okay. Which will be equal to q by 2a into dy. I've substituted lambda value here. Now apply the electric field formula that is only applied for your point charge, because it is derived from your Coulomb's law only. So dE will be equal to what? K dq by r square. Okay. Which will be equal to what? You just substitute the value. So here you have dq value is coming out to be what? Q by 2a into dy. So substitute that only. So it will come like k q dy upon 2a into r square value is x square plus y square. This is the value of your dE. dE value is coming like this only. Okay. Now you can observe here that dE has two components. See the figure once again. dE has two components here. dE is like acting in this direction. Okay. And it is making theta angle with the x-axis. Okay. So this has two components. dE x. dx is the dE cos theta. Okay. And dy is d sin theta in the negative y direction. Okay. And this is in the positive x direction. So just see the next calculation. If you now this, now if you see the further calculation, it has yes. So here d cos theta value is what? Your q by 4 pi epsilon naught, or k q x dy upon 2a into x square plus y square into 3 by 2. Why? Because dE cos theta is there. So you have just find out the dE value. Now cos theta value is what? Here it is equal to x by x square plus y square to the power half. Okay, because this triangle, here see the triangle, have the cos theta value equal to cos theta value. This is your triangle here. This cos theta here is what? Your x upon this r, and r value is root x square plus y square. So that is why we have this formula of your dE cos theta. This is dE cos theta only. Okay. So this is your dE cos theta, and if you now simplify it, it will come as k q x upon 2a x square plus y square to the power 3 by 2, because here one power is there and 1 by 2 power is there. So 3 by 2 power will be there. Okay. And here you have dy also here. Okay. Like this. So you are getting like this. Okay. Let's see the next calculation part. So yeah, you are getting like this, and d sine theta is coming like your k q y dy upon 2a x square plus y square to the power 3 by 2 with minus sign. Because here the sine theta value is what? Y upon x square plus y square to the power half, similar to cos theta. Okay. So ex value, if you integrate it from g minus a to a, because here variable is dy only. So if you calculate like whole value of d cos theta, so it will come as x. Ex will be coming out to be equal to k q x upon 2a into x square plus your what, like y square only. Okay, y square to the power 3 by 2. Yeah. And you have to now integrate it from what? Integrate it from minus a to a, because limit of y should be applied here. It is integration in terms of dy. So in like limits of y are what? The length is varying, or the line charge length is varying from minus a to a. So that is why minus a to a limit is there. Okay. So if you calculate now ex value, so here ex value will come what? K q upon x into root x square plus a square. After putting the limits, you will get this answer. Okay. Integrate it like you must integrate it like what? And here x square plus y square to the power 3 by 2 is there. So if you integrate this part, you will just apply like your kqx is there. Okay. And upon 2a, this is your constant term because it has no y term. Okay. So no y term is there. So you just have to integrate this part minus a to a upon, this is your x square plus y square to the power 3 by 2, and it should be integrated with dy. Okay. So this integration, if you integrate it, you will get the answer as what? So you will get it like x into root x square plus a square. Okay. Just integrate it and you will find the value. Okay. Just a second. Yeah. 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 So you have to integrate, you will get this value if you integrate it. And if you integrate the ey term, then it will come equal to 0 only. Because if you put the limit a and minus a, then it will be cancelled out by first positive term and other negative term. So the net electric field will be ex only. That will be equal to k q upon x into root x square plus a square. Okay. So from this expression, what we have observed that the final expression, we can see that if x is very, very greater than a, ex is equal to 1 by 4 pi epsilon naught q by s square. Because here a, like a term will be neglected because x is very, very greater than a. Okay. If we make the line of charge longer and longer, adding charge in proportion to the total length, so that lambda, the charge per unit remains constant. Okay. So these are all points like lambda will remain constant here, like this only. This is saying, so ex will become lambda by 2 pi epsilon naught x. This is the like we have already discussed this. This is the case of your infinite wire, line wire. Okay. So this already we have covered. So let's move further and see that what is the next topic or what is the next question you have to discuss. Till now we have discussed some good questions and 3 questions are discussed. Okay. Let's move further and see what is the next topic or discussion. Okay. So till now we have seen two questions and that were from your electric charges and Coulomb's law, and also from like your electric field. So now we will discuss one question from dipole and then we will continue to our next chapter, that is your electric potential, electrostatic potential and capacitance. So let's move further and see that what is the next example. Okay. At like example, there is example what is said at a far away distance r along the axis from an electric dipole electric field is capital E. Find the electric field at distance 2r along the bar perpendicular bisector. So along the axis of dipole, what we have the formula? This is the formula that is for axial point. We have already discussed that 2p by 4 pi epsilon naught r cube is the dipole formula electric field. Okay. This electric field is in the direction of P. It is in direction of P only. We have seen also this along the perpendicular bisector at a distance 2r. Okay. Just a second. Okay. Along the perpendicular bisector at a distance 2r, we have the E dash which is equal to 1 by 4 pi epsilon naught P by 2r cube. This we have already seen that like if you have yeah, 2r distance like this, you have perpendicular bisector. So this is the case of equatorial point. Okay. So here you have the like if you apply the electric field formula, so it will be equal to P by 4 pi epsilon naught 2r the distance, so 2r whole cube. So from equation 1 and 2, we can see that E dash is equal to what? E by 16, because it is coming out to be 1 by 16 times. So E by 16 is the value of this. So moreover, E dash is in the opposite direction of P, and it is in the opposite direction. We have already seen that the like electric field direction in equatorial point is in this, and at axial point it is in this direction. Okay. So direction will be like opposite. So E dash would be equal to what? Minus E by 16 in the vectorial form. Okay. So that is the like your this question that was very simple. So yeah, we have just seen many questions on your previous step like topics or chapter. Now first chapter is your like over, and we will now go to next chapter, and let's clear this drawing. Okay. We have already seen some questions on electric flux, so we will now move forward to the next chapter. Just I will move this part, and yeah. The next chapter is electrostatic potential and capacitance. Okay. So till now we have already seen that what are electric charges and what is your electric field, and how the electric field lines like behavior of that, and what is your electric flux, and yes, cause law. These already we have covered in the first chapter, and now there is application part of these all, like your electrostatics which will be applied on your capacitance, and electrostatic potential is your like another topic for understanding the capacitance terms. So we will see that also. So let's start with your first topic, that is electrostatic potential difference and electrostatic potential energy. So what are these things? We will see in detail, and also observe that what is the difference between all these terms. So let's start the discussion, and if you have any type of doubts or comments, you can post in the chat box. Okay. So yeah, let's start the discussion. So the electrostatic potential at any point in the region of electric field is equal to amount of work done in bringing a unit positive charge as charge without acceleration from infinity to the point. Okay. So what is electrostatic potential actually means? Yeah. So if you have yeah, if you have like electric field anywhere like this, and you have like any charge, unit positive charge means plus 1 coulomb, like you can say that this is your test charge. Okay, so you have like this charge which is in infinity. Assume that infinity, it is at infinity, very far away from this electric field. So there is, if you like bring this charge very slowly to this like opposite opposing this electric field. So you are like applying some type of push here or force here, like you are applying here very slowly. That's this force is very negligible, or there is no acceleration or net acceleration on this charge. Okay, there is no net acceleration on this charge. It is moving with constant velocity. Okay, very slowly. Okay, so after like moving it through this point, and like if you have this point here electric field, and you have moved it for like on this point, then the work done by bringing this charge from infinity to this point, the net work done in this path will be equal to what? Electrostatic potential. Okay, this is called as electrostatic potential. So this is a term which is related to work done. Okay, so we will discuss with like we will denote it electrostatic potential by what? V, capital V, that is equal to work done by unit positive charge, or work done upon unit positive charge. Okay, Q naught. That is related to work done. It is a scalar quantity. Why it is a scalar quantity? Because it does not have any magnitude. It is a work done. Like work done term is that the work is already a scalar quantity, so that is why it is a scalar. Okay. Its SI unit is volt. SI unit is volt, and 1 volt is what? 1 joule per coulomb. Its dimension formula is ml2 t minus 3 a minus 1. Okay. So I hope that you understood what I have told you. That electrostatic potential is your work done to bring any unit positive test charge from infinity to any point, or like in any electric field point, and the work done is against that electric field. Okay. So yeah, let's move further and see what is the next thing. So work done work done like infinity to external by an external force in bringing without acceleration a unit positive charge from infinity to a point is equal to the potential at that point. Okay, so that I already told you that if you like work done, any external agent is doing the work done in bringing any unit positive charge from infinity to a point, then it is called what? Your electrostatic potential. Okay. So this is like here it is already mentioned here. Okay. Yes. So potential like electrostatic potential can be positive, negative, or zero depending on the signs and magnitude of Q and W. So like electrostatic potential can be like positive also, negative also, or zero also. It depends on the charge, like magnitude of charge and your work done. Okay. Now we will see that what is this example we will discuss. Okay. So just remove these drawings. Yes. So what it says, potential at a point P in space is given as 3 into 10 to the power 5 volt. So this is the potential at any point in the space. Okay. Find the work done in bringing a charge of 2 into 10 to the power minus 6 coulomb from infinity to the point P. Does the answer depend on the path along which the charge is brought? So we have to find out the work done in bringing a charge from 2 like infinity to the point. So it is like asking you the electrostatic potential value, because it is the case of that only. Infinity to the point is what? Electrostatic potential. The given potential at point P. The potential at point P is already given here, which is equal to 3 into 10 to the power 3 volt. And charge is here Q naught. That is the test charge. So it is equal to 2 into 10 to the power minus 6 coulomb. Okay. So work done in bringing the charge from infinity to the point P is what? Your Q naught into V. Okay. Why Q naught V? This is not test charge, this is your source charge. Okay. So here you can see that this is your source charge. So work done is what? burden in bringing any. Just a second. Yes. Yeah. This is a charge like your uh, uh, small charge. Okay. So you already have seen that V is equal to work done by Q naught. So after cross multiplying it, you will get work done is equal to Q naught into V. So Q naught value is what? 2 into 10 power minus 6 here, and 3 into 10 power 5 is your potential value. So you will get 6 into 10 power minus 1 joule. So it is 0.6 joule. So no, the work done will be path independent. Okay. And you have already find out the work done, and it will be path independent. Why is it path independent? Because electrostatic force or electrostatic work done is what? It is non like your, it is a, your, you can say that conservative force in nature. Okay. Why it is conservative? Because the work done at in like by any path is independent of that path. Okay. This same only. So it is a why what conservative force. So till now we have discussed like many questions and many examples. Also we have covered the electrostatic potential terms, and I hope that you got whatever I taught you today. And that's like we'll discuss next thing in next class because time is running out right now, and we have already discussed many things today. So if you have any kind of suggestions or comments, you can like you post in the chat box and also in the comment also. And if you want any like private session or one-to-one session, you can also tell this. So yes, I hope you like the session. Thank you and have a great day for today.